Lesson 2-5, the graph of y equals kx squared. The big idea is the graph of the set of points x comma y satisfying y equals kx squared with constant k is a parabola with the vertex at the origin and containing the point 1 comma k. Okay, so what that's telling you is you automatically know it's a parabola. Remember, parabolas look something like this, or they look something like this from Algebra 1. Okay? But what they're telling you is automatically you could graph a parabola by simply putting 0, 0 in and then 1 comma k. So if I do 1 comma k, wherever k is, 1 comma k, k might be here, I can graph that. And since parabolas are symmetric, if I go 1 over this way, it has to be the same height as well. So there I have my parabola. Okay? Looking at this graph, okay, they're talking a distance formula that was d equals 1 over 20 s squared. Okay? So if you look at this, if you put 0 in, you get out 0. 0 squared is 0. 0 times 1 over 20 is 0. If you put 10 in, you get out 5. You put 20 in, you get out 20. 30, you get 45, so on and so forth. And they graphed these points, okay? S being our speed, miles per hour, and our braking distance formula, which is d equals 1 over 20 s squared, is what I get out when I'm going a certain speed. So if I'm going 60 miles an hour, it looks like it's going to take me roughly 185 feet to stop my vehicle. Notice this does have a shape of a parabola. Now, we're only looking at the first quadrant because you can't have negative speed, okay? But if we were to look at this graph at the negative side, you would notice that this comes out this way as well. Okay. Rates of change. The points on the graph above do not lie on a straight line. You can verify this by calculating the slopes of the lines through different pairs of points on the graph and seeing that they are not equal. So what they are saying is we could go back here and check our slope. Well, if you go from 0, 0 to 10, comma 5, well, 5 minus 0 is 5. And 10 minus 0 is 10, so that's 1/2. And let's just pick an easy one. 45 minus 20 is 25. I'm just doing my slope, y2 minus y1, x2 minus x1. 30 minus 20 is 10. This one equals 2.5. This one equals 1/2. So yes, as we can tell, these points do not lie on the same line because they have different slopes. Example 1, finding the rates of change and explain what each means in terms of braking distance. Okay. A says R sub 1, the rate of change from 20, comma 20 to 40, comma 80. Okay. So I'm going to call this my x1, y1. I'm going to call this my x2, y2. Okay, so 80 minus 20 divided by 40 minus 20 is equal to 60 divided by 20, which is equal to 3. Okay, what does this slope mean in terms of braking distance? Okay, well, that means from 20 miles per hour to 40 miles per hour, okay, my braking distance is going up relatively 3 feet for every 1 mile per hour. So it goes up distance goes up 3 feet for every mile per hour. Okay? So from 20 to 40 miles per hour. Okay, that's a very special thing to note. From 20 to 40 miles per hour. When it goes from 40 to 60 miles per hour, I take 180 minus 80 divided by 60 minus 40 equals 100 over 20, which is equal to 5. So what does this mean? From 40 miles per hour to 60 miles per hour, the distance goes up 5 feet for every 1 mile per hour from 40 to 60. Does that make sense? So as your speed increases from 40 to 60, okay, your braking distance gets much greater. Okay? The rate of change between different pairs of points on the graph of d equals 1 over 20 s squared is not constant. Two conclusions can be drawn. One, the graph of d equals 1 over 20 s squared is not a line. Yes, we know that. It is a parabola. And two, a single number does not describe the slope. Okay, we checked multiple places. Okay, slope was different of the whole graph. Notice that slope is larger when the graph is steeper, meaning the braking distance increases more and more rapidly as the speed increases. The equation, so this would be direct variation, correct? The equation d equals 1 over 20 s squared represents a direct variation function of the form y equals k times x squared. All graphs of equations of this form share the same properties, and you should be able to sketch graphs of any equation of this form. Perfect. Moving on. Quiz yourself 1. Calculate the average rate of change between A and C in example 1. Please explain what it means. So I'm going to take 180 minus 40. That's my y2 minus my y1. This is my x2 minus my x1. And 60 minus 20 equals 180 minus 40 is, you're going to tell me 140. And you're going to say 60 minus 20 is 40. Do your math. 140 divided by 40 is going to give you 3.5. And so what that means, the slope from 20 miles per hour to 60 miles per hour is going to increase approximately 3.5 feet for every mile per hour. Okay? The graph of y equals kx squared. This is important that you're going to want to write down. All the graphs in the family of curves with the equation y equals kx squared with k cannot equal 0 are parabolas. No matter what value is chosen for k, the parabola passes through the point 0, 0. This point is the parabola's vertex. Okay, we've talked about that before in Algebra 1. Vertex. Further, each parabola in this family coincides with its reflection image over the y-axis. So the y-axis is symmetric. Okay? Whatever I graph on this side, I could graph the same thing on the other side. And the y-axis is called the line of symmetry. So we call this line the line of symmetry. because if I were to draw a line, it would split that baby right in half. In general, the domain of the function with the equation y equals kx squared is a set of all real numbers. As you saw in this activity, when k is greater than 0, the range is a set of non-negative real numbers. And the graph of the function is a parabola that opens upwards. When k is positive, we get a parabola that opens upwards. When k is negative, we get a parabola that opens downwards. Okay? So if you look here, this is very important to know. You're going to want to write these two things down. When k is greater than 0, my domain is the set of all reals. Okay? I could put in any number. I could get out something. My range is the set of non-negative reals. Why is it the set of non-negative reals? Well, we can't get any negative values out of this. We're always going to be positive. When k is less than 0, which means you have a negative number, that means your domain is still the set of all reals because we could put any number in there. And the range is a set of non-positive reals. Okay? Non-positive reals. Because the answer we're always going to get out is negative. Without using a graphing utility, sketch rough graphs of y equals a negative 2x squared and y equals 2x squared on the same set of axes. If you remember, at the beginning of the lesson, they told us that 2 points that are going to be on the line is 0, 0, and 1, k. Okay? So I'm going to use that to my advantage, and I'm going to graph both of these. So 0, 0 is on for both of those. I'm going to do this one first. And you can do this on your calculator, but sometimes you can do these very fast. So I graph 0, 0. If I put 1 in there, what do I get out? Well, I get out a negative 2. So if I put in 1, I get out a negative 2. That means if I put in a negative 1, I'm also going to get out a negative 2. Because a negative 1 squared is a positive 1. 1 times a negative 2 is a negative 2. So my parabola is going to look like this. So this is my y equals a negative 2x squared. To graph this one, and I'll do this one in red. Okay. I graph my vertex. I put 1 in. 1 squared is 1 times 2 is 2. So if I put in a negative 1, I also get out 2. Remember, symmetric. Yes, my graph is not that pretty, but you get the idea. These were supposed to kind of look the same. But if Mr. Johnson was able to be a better artist with this bamboo tablet, you would see that these two things would be symmetric. It's just that one opens upwards, the other one opens downwards. That's all I have for you today. Please enjoy this wonderful world of mathematics. Have a good day.